I just wanted to show you this fly. I'll try a close-up, but this flip camera doesn't do close-ups well, but I'll get in a little bit closer. But it's just a dead fly that's on this gate here. There it is, look. The reason why I'm showing you this is I've just been thinking about complexity and space. And you know, and well, pretty much I guess, in the frame of the picture you're looking at right now, the most complex thing is inside the head of that little tiny fly there, look. I mean, obviously it's inactive right now, but certainly when it was alive, the amount of information that was being integrated in that little tiny speck at the centre of this picture is far in excess of anything else you can see there, unless you can see other flies, of course. It's amazing that, because I mean, one of the things I've been thinking about lately, I made a video about this yesterday, is it's just, you know, the scale of the universe. You know, I'm not, you know, there's that famous, what's it, that famous song in Monty Python's Meaning of Life, you know, where I think it's Eric Idle does this song where he talks about how big the universe is and how dwarfed we are by comparison, and how meaningless life is because of the sheer immensity of everything, you know, and the fact that we are here for a tiny glimmer of time and we occupy such a minuscule amount of space, in the great scheme of things renders it insignificant. And it's a very convincing argument, you know, and I certainly can't look at pictures of space, of the Hubble Space Telescope, without being reminded of that. And I was listening to a video a couple of days ago which was talking about, I think it was one of the TED Talks actually, which was talking about the fact that our galaxy's got 100 billion stars, and in a universe, a visible universe that's available to us at least, has got 100 billion galaxies, so that's a lot of zeros. And you know, the number one that we represent is a pretty small ratio, you know, in that mathematics, isn't it? So we do feel a bit, at least I certainly feel a little bit of existential dread when I think about those figures. But one of the things I've been trying to think of is, well, not as an escape from that, but just as an interesting, for myself, interesting reflection on that, is to do not so much with space, but with complexity, or about the relationship between space and complexity. Because, you know, obviously the universe is pretty complicated, and atoms are complicated things, and chemical compounds and elements are complicated things. But they pale in insignificance compared to the complexity of biology. This is something Gerald Edelman talks about, actually. You know, biology is far more complex than, as a science and as a set of processes, than the chemistry that it's composed of, and chemistry again is more complex than the physics that that's composed of. And then once you get to kind of the information processing capacities of complex biological forms, particularly those with brains, but even things like cells, you know, but cell membranes are complex. But things like brains, cognitive processing, is enormously complex. I mean, it just, you know, everything else pales is reduced in size, comparatively speaking, if complexity was a factor to be taken into account. And not just complexity in and of itself, but the integration of complexity. You know, here I'm thinking about, what's he called, Giulio Tononi, I think he's called. Oh, if you just go through it. Giulio Tononi, who writes about integrated information. He's got this theory, IIT, integrated information theory, which, and he's got this mathematical formula. I don't know how it works exactly, but it measures the degree of information the degree of integration that complex information can have with, obviously, the most complex integrated entities that we know about being brains, particularly human brains, which are capable of integrating enormous amounts of information. From what I understand, the maths and the equations that he's got to measure that are so complicated that in and of themselves that we aren't even close to being able to measure even the complexity of the brain on that little fly that I saw back there. You know, it would take more computing power than in the whole world we've got right now just to measure the degree of integrated information that exists within a fly's brain. But you know, the potential is there in the future to be able to carry out that kind of an assessment, and that's a really significant factor, isn't it? So I'm trying to reimagine, you know, what would the universe be like if if instead of, you know, having this kind of experience, which is all to do with spatial extension of middle-sized objects, really, you know, that's kind of what we see, isn't it? You know, we look up and we see spatial extension in 3 dimensions. If instead of this being the universe was mapped according to its complexity and according to the degree of integrated information it contained. You know what I mean? So what you would do is you would take this space, the universe, with everything in it, dogs, people, trees, water, the air here, the vacuum of space. You would take all that stuff and maybe divide it up into a grid. You know, you would slice it up into 1 centimetre cubes. Let's say you did that. You know, so everything was just cubed. And then you would apply Tononi's calculation. This wouldn't quite work, but you get the idea. You would apply Tononi's calculation to measure the degree of complexity in each one of those centimetre cubes. Yeah, so it'd be low complexity, low complexity, low complexity, low complexity, high complexity, high complexity, higher complexity, high complexity, low complexity, low complexity. You know, as it moves through things. And similar things here: low complexity, low complexity, low complexity, higher complexity, high complexity, low. You know, so you would measure those things, and that would give you a numerical value for each one of those cubes. Can you imagine that? Each one of these cubes that fill the universe would have a numerical value, and then what you would do is you would remap that onto a different kind of space. So anything that had any centimetre cube that had a high numerical value because it contains a high level of integrated information, high complexity, that would be expanded to match the complexity value. And things in cubes like this bit here, it's just got like nitrogen and oxygen stuff moving around in it. This cube here would have a low complexity, low integrated information value, and so it would shrink. And interstellar space, which has just got quantum fluctuations going on in it, well, it's really simple by comparison. It'd be tiny, tiny. So, and then you remap that, you know what I mean? So what would the world look like? What would the universe look like with that remapping going on? I think what it would look like is the whole universe would be like wall-to-wall brains. You know, like brains just crammed in next to each other, packed full of brains, the whole universe just full of brains, separated by this very thin film, a coating around each of these brains. You know, because my brain and your brain aren't connected apart from through this language, so it's a relatively low level of integration between our brains. A little bit, but generally not much. So the degree of information, integrated information, that the rest of this stuff contains would just be like a thin film, a thin membrane, separating these big brains and these smaller brains, the brains that my dog's got. Of course, that would be in there as well, because that's really complex. So I would be pressed up against my brain would be pressed up against Phoebe's brain like this. Come here, Phoebe. Let's see if I can demonstrate this. Come here, Phoebe. Come here, Pop. Come here, Phoebe. Look, like this. It would be like this. Yeah, like that. Pressed up right against like that. And you know, with the universe, all this stuff, everything else, the entire universe, the entire Hubble Space Telescope revealed universe would be just this really thin skin between our brains, you know, like a membrane. And there'd be things passing through it, you know, there'd be osmotic processes going on between this membrane. And it would be a really important membrane, don't get me wrong. You know, the whole universe would be a really important skin around us that we want to protect, and we want to monitor the health of, just like you want to monitor the health of your own skin as a human body, don't you? But the universe would be a skin around all of our complex cognitions. Yeah, that would be interesting. That would bring the scale home, you know what I mean, rather than just a space thing.